Hello and welcome to Mr. Barton's autograph video number 45. Now this week we're going to continue our look at all things to do with 2D graphing. I'm going to focus our attention on illustrating tangents and the gradient function on autograph. But before we start, if you happen to be interested in using the gradient tool on autograph, which is absolutely ideal to demonstrate calculus and specifically differentiation from first principles, then can I recommend that you have a look back at video number 27, I think it was, where I do you a nice little demonstration of how to use this tool to show off some really nice stuff. So that's autograph video number 27. But this week, let's crack ourselves open a brand new 2D graph page. You need to be in advanced mode for this one, and we're going to start by drawing the classic curve y equals x squared. Now enter equation, y equals, I'm just going to do xx for x squared. Now of course we never click OK in autograph until the students are happy what it's going to look like, and we've chatted about all that kind of stuff, but when we are, we can click OK, and there it is there. Now the chances are that your students will have only met tangents with reference to circles, so a nice way to get them to understand what a tangent is to pop one on and get them to describe what's happening. So go into point mode and you get this lovely little cross, and when you hover over the curve itself it goes to a black arrow to show the points attached to the curve, so give that a click, and if I right click with my point selected I should get tangent. And there's a lovely tangent, and now I can drag on that point and I can move the tangent around and get the students to explain what's happening. Now we can start to talk about the gradient function of this curve, and we can have a look and see that the tangent starts off pretty negative, the gradient of it goes flat and then goes pretty positive. We can actually show the equation of this tangent. If I just select the tangent and click on text box, and I think I'll go for a nice little ice blue, and click OK, then we get a lovely little dynamic text box which will change as the equation of the tangent changes, which is quite nice. But what's really nice is that you can use this to show how the curve y equals x squared and something like y equals x squared minus 2 or plus 3 actually have the exact same gradient function. So if I pop a new equation on, so let's go for y equals x squared minus 2 and give that a little click, we get that. Now one option is I could just pop a point on here. So pop one there, right click, and I could get tangent, and I could try and line up these 2 points to show that the gradients of the tangents are the same and those tangents are parallel, but that's a little bit fiddly and it's not entirely convincing to the students. So what I'm going to do instead is I'm going to give this a little double click there, and that gives me the x coordinate of my point. I'm going to change that from a numeric value to a constant, which autograph will automatically default to be 1. Give that a little click, and I'm going to do the same thing with this point, so double click on that, change that from 1.1 to a, and what I've got now is 2 parallel tangents. But better than that, if I click the constant controller, I can increase the value of a and decrease the value of a, and I can show the students that as long as the 2 x coordinates are the same, the gradients of those 2 tangents are exactly the same, and therefore the gradient function of those 2 curves is exactly the same, which is quite a powerful little demonstration. But wouldn't it be nice if you could plot the gradient function of any curve? Well, the good news is this is autograph, so it certainly is possible. If I'm making a bit of a mess of this, if you just select everything and just delete them, so we're just left with our nice little x squared curve. First thing to do is make sure slow plot's on. So that little tortoise or tortoise or whatever it is, make sure he's on. Click on the curve itself, it should go black, and if you hover up to the top here you get gradient function. So I give that a click, you get loads of nice options. I'm just going to make sure I've got myself a dash line, and I'm in the mood for a bit of a blue one I think there, so give that a click. And when you're happy, click OK, and it will do the same, autograph will do the same thing with the tangents, but this time, every time it creates a tangent to the curve, it will plot the numeric value of the gradient. It will also pause at key points to allow you to question your students about what's happening. To resume it, just click pause again. You can pause it yourself at any stage. And there it is, it shows you the actual gradient function of that curve. And then we can start to say to the students, okay, well what is that gradient function? What is the equation of that line? Now you can link that back to autograph video 27 if you want, for showing exactly where it comes from. Or you can do a classic thing of just trying to work out what the equation of that line is by drawing a right angle triangle or something like that. And when the students think you've got it, so let's say, oh, is it y equals 2x? Well, let's have a look, let's draw it. Click the turtle off, and it is exactly y equals 2x. So there's a gradient function that can be used for quadratics, cubics, whatever you want. And that's me done for another week. See you next week. Bye bye.